Good morning, good afternoon, good evening, depending where you are watching us tonight. We're very happy to have you here with us. This is our first 2022 event. I would like to ask you to use the chat to ask as many questions as possible. We want to make this very interactive. So why don't you start, go, let us know your name and where are you watching us tonight. I also would like to tell us to follow us on Twitter if you're not following us on Twitter. At NYJavaSIG. We're very active, is where we post everything, all of our events. So please follow us on Twitter. And here, since you are on YouTube, click on the subscribe so you get notified about all of your events, and you have access as well to all of our videos from previous presentations. First of all, I would like to thank our sponsors, JetBrains and Agile Learner. They're very nice. They gave us a few licenses that we're going to be raffling at the end of the event tonight. So please stay with us until the end of the presentation. We're going to raffle 3 or 4 JetBrains licenses. They are valid for any IDE from JetBrains. IntelliJ included, of course, and we're also going to raffle a 1-year subscription to Agile Learner. Agile Learner is from the Java champion Venkat Subramanian, has a lot of great content. So stay with us until the end of the presentation so you can participate in the raffle. I would like then to call our speaker tonight. Ana Maria is a Java champion, a developer advocate, co-founder of the Bucharest software craftsmanship community. I also had the pleasure to work with Ana at the TDC coordination of the Java International track. Ana is a great person, and I'm very looking forward to watch her presentation tonight about cloud native resiliency patterns from the ground up. Ana, very nice to have you here with us tonight. The stage is all yours. And thank you very much for being late tonight. I know it's late for you, so thank you very much for being here with us.
Okay, thank you very much for inviting me. First of all, Happy New Year to everybody. Hope you had a good start in 2022. And yes, well, I hope you'll enjoy the presentation. If anything unexpected happens during the presentation, well, it's midnight, anything can happen. It'll be a little bit like Cinderella's story, probably. Well, let's see, and let's talk. And if the screen is, yes, it now is being shared. So let's speak about cloud native resiliency patterns from the ground up. As Rodrigo has said, I'm Anna. Besides being a Java champion, I'm also a certified architect. I love to experiment a lot around using Java, but also other technologies that can be combined with Java to produce much more better architectures if possible, much more better performance for applications. I'm a Kubernetes fan. I like Kubernetes. I like OpenShift. I certified myself for these with these technologies. But in the end, I would like to admit in front of you that I'm also a control enthusiast. And probably many of you as developers, as professionals working in IT, feel the need to control what you're doing, what you're working, especially when it comes to the applications that you're working on, right? So speaking about control, I'd like to ask you something, and you can also answer to me in the chat. How do you feel when an application is too busy or not available? So for example, let's take an example like now it's sales time, right? Because we're like in January, everything is on sale. If you're like not buying a sweater from a certain brand or something, it's not like the end of the world, I hope. And you can come back later to a website that's not available because it has too much traffic, right? But for example, if you're doing something very important for you, like, I don't know, paying your taxes, and that website is not available or is responding not too well to your requests, that's bothering you because that's actually vital for you to actually do something in your life. And then, well, it's an application done by somebody else. Maybe you get a little bit frustrated, but most of the time you're gonna come back later and try to do the work that you are intending to do. And the same picture, the one that I put here, is one that you can also see when your application is too busy or not available. If you have experienced this with the other kind of situation, and then you're looking to your application, you kind of know that sometimes which is written here is probably the first one. The application is not available or too busy. And hopefully is available in a few moments, but this is what resilience is good for, like to make it available in a few moments. So this is why we're having our talk today here, so that we can see some options that are available out there for our application code, for infrastructure, to make our applications resilient and to be available again in a few moments. So what is resilience? Before looking into like definitions and all these sort of things, you can think of resilience to a set of behaviors that your application is going through. So most of the time your application is in this state, the normal behavior here. But when an unexpected condition occurs from outside, that normal behavior becomes different. And then an unexpected event occurs inside your application, and that application that was like perfectly working and that you thought very well and you tested so well and you thought to so many good scenarios and when it's going to work perfectly, gets into faulty behavior mode. Now, in this case of a faulty behavior mode, you have to kind of have an anticipation and a way to detect, to recognize that malfunction. And typically you kind of implement a detection control mechanism to recognize malfunctions. And based on those detection control mechanisms, you can also get from those some feedback. That feedback can mitigate somehow the malfunction and get your application into a so-called degraded mode behavior. Now, why I'm calling this degraded mode behavior, because it's most of the time something that's like, let's say it's 99.999, as many nines as you want, behaving like the real thing, because we're kind of trying in this, when we're getting this feedback, to like put the application into a state where it is behaving as better as possible so that it can give the seamless experience to the end users, right? Well, after it gets in this place, and we don't like to stay in this place for a long time, what can happen to our app? Well, it can recover. and get into the normal behavior again. So resilience is like maintaining these states, like when something bad has happened, not to go immediately offline, not to make our applications unavailable, but to actually keep them there available and keep them up and running, and like nothing has happened for our end users. Although that behind the scenes, probably we have logs where we see that things are not so nice and there is some pressure on our system. Now, let's look again, what is in our control? So in our control, there are three things as developers: the detection control mechanism, the feedback control, and the recovery control. So we can control these things, and see control all over the place because we were talking about control earlier. And we can control these via our implementations at application level, and of course at the infrastructure level. And I've talked to some folks in the past, and they were thinking also of like making some resilience also with the pipelines, but that's a topic that I'm still investigating. And we're going to look into a few things like these today. So where to start? Well, as a Java developer, probably you have started by looking at a very popular blog, and you've seen the circuit breaker pattern. And this pattern has started to be very, very popular. I think everybody was talking about it intensively. Nowadays, it's being talked intensively as well, but I've heard it way much more in 2017, 2018, that everybody was like, whenever there was I was hearing resilience, somebody was jumping in and saying circuit breaker pattern. Okay, I got it. But we should evaluate some other solutions as well and see if this is enough. So the circuit breaker pattern, what happens is that when there's a problem, there's a possibility for you to open the circuit to stop the problem, to stop, sending requests to a problematic endpoint, and then to investigate if the problematic endpoint is feeling better. In the case it's feeling better, then you can again close the circuit and go back to the normal behavior. So it has that recovery inside it. It has the detection control. It has all the possibility to give you a feedback and also to do the recovery. So it kind of addresses all that. But is it enough? And I'm going to show to you if just only this is enough. And those being said, let's go a little bit into the coding part. Before reaching to the coding part, I need to tell you a story of what we're going to build today. So we're going to look into two microservices, and we're going to look more to the part where we're going to consume an API. This is called the board API. It can give you some activity. This API gives you some activities to do depending on the amount of participants or the price, or how is the accessibility for such an activity. And we're going to consume information from this API in one of the microservices and test its resilience in certain situations. For building my microservices, I've used Quarkus, and both for the backend part and also for the front-end part. It's a combination there at the front-end level, Quarkus and something else. I suppose that it should be enough to showcase my examples for you today. For the Quarkus part and for the activity microservice, I have got to code.quarkus.io. And for example, here you can also generate your own project. And I know I written here Kubernetes, but I don't remember why I did this. Since I'm consuming a service, I would probably need a REST client. And I've used this one. Since I'm also exposing some services, and nowadays I think the most comfortable protocol to use is REST. So I'm also going to use Quarkus or CZJSONB for this one. Well, I said I'm going to need to make it resilient, so I need to do like fault tolerance. And well, any good application, good cloud native application nowadays, it's not only resilient, but you also need to check how healthy it is. So I need to check a little bit how healthy it is with small I health. And yeah, I also need Swagger to see what's going on with my services. For building containers, in the containerized part, I've used Jib. And yes, well, I've also used the Kubernetes to generate the generator for Kubernetes resources from annotations that Quarkus has as an extension. Because I also like to have some, code bootstrapped if available, why not? And then just decorate it also over. So this is how I generated my first microservice, only by using these 7. The reason why I prefer to use Jib, for example, is because I wanted to use Java 17. And with this extension, I am able to swap very nicely the base image. Typically, when you are generating this one here, it gets generated default with Java 11, but you can also switch it to Java 17 and build your own container image natively with Java 17. All the code will be available for you in GitHub, so everything is opened there. It's nothing that I will keep away from you. And of course, my deployments and everything that I'm going to deploy, it will happen today on an OpenShift cluster that I have, but I have provided code, the Kubernetes part, working on any sorts of, if you have Minikube, it will work for you, don't worry. So let's look at the activity microservice. And the activity microservice, as explained earlier, it is consuming some information from the board API. So you can see here, the board API being referenced. And besides, consuming this information, I can have the implementation of, well, the so-called implementation, but it's an interface activity service where I am registering this REST client and consuming the endpoints available there. Going into activity service, I have some sorts of endpoints already coded here for consumption. Everything is fine. And let's start the application. First of all, let me check it's Java 17. Okay. And start with NVN Quarkus dev. I changed a few things in the POM to work with Java 17, like, well, the compilation, the compiled version, which is 17 now, not 11. But you will see everything in the GitHub too. So far, the app has started. That's cool. Let's just go here to localhost 8082. Not hello, dev UI, and go to my Swagger UI to check how my app is behaving. And I think I want to do this one, activity by type. Yeah, activity by type, and I'm going to try it out and see if everything's fine with it. I hope it's fine. It's midnight. I'm having a little bit of, hesitation. Oh, things are good. So things are good. I'm getting a response. I'm consuming everything. Really, really nice. Cool. Now let's do something bad to our app, right? Because we're at the resiliency talk. And to provoke something bad, we're just going to change this part here and consume for board APIs, which doesn't exist, of course. Let me go to the board API and just to check that board APIs doesn't exist. Oh yeah, it doesn't exist. Cool. Let's do the same now and execute. Yeah, well, without any sort of, handling of the situation, there's no detection control mechanism for this unexpected situation, the end user probably would get something really bad based on this very not so nice stack trace here. What to do in such case? How to avoid these kind of situations? Because whenever you depend on something that is not under your control, this can happen. So you cannot rely that external party that you're not controlling is always going to be up and running and behaving as has promised you. It's good to have faith in such things, but it's also to have it's good to have a backup plan and a plan B for unexpected situations as well. So let's handle a situation for this one. Oh yeah, everything's bad. We don't like this. And let's go here. So this was the method that I was trying to invoke, and it was not behaving as good as it had happened before. Let's start with the circuit breaker pattern. So what I can do, I can annotate this with that circuit breaker annotation from microprofile, and use the circuit breaker to like say, okay, when 75% of the requests that I'm sending to this endpoint, to this consumer endpoint are failing, then well, you should open the circuit. But you should like try again, like maybe in 3 seconds, maybe in half open, maybe things are now looking great and it's just like a momentarily problem. It's nothing that is happening like all the time. Let's not be dramatic. But we're looking now here and we see that we know how many will fail and when we should try later. We should also think like, what if we get this response that something is failing, but it counts like ages? We are waiting a lot of times. Our application, our end users are waiting a lot of time for a disappointing answer. In this case, you can also put a timeout annotation, also from microprofile. And you can put a default value. You can use either the default value or can you put your own value, like how much time to wait for this. And you can say 300, for example, for the timeout here. How much you like to wait for that request to happen, or like 150. Let's be a little bit more conservative. When the timeout is gonna, fail, if there's a failure, of course, then a timeout exception is going to be thrown. This timeout exception can be reused by putting here another annotation called a retry. And like when timeout exception is being thrown, it can also instruct retry on like trying a little faster what it's trying to do there. Because the retry can help you, by the way, into reaching this failure ratio or like getting to the failure ratio earlier, opening the circuit and then, stopping the problem. So let's say the retry, let's say some max retries 4. Also put some delay between the retries, maybe, I don't know, something good will happen, like put some 100 seconds between it. So now we have all these situations. Like we know we can like handle granularly, like how much time it will take, how many of them can fail. When to try again. But what about our end users? They deserve something, right? So maybe let's add a fallback and give them something as that degraded mode behavior before, giving something else. This kind of idea of like offering a fallback, even if it's a dummy fallback, can be later on taken by, I don't know, the front-end level of your platform and transformed into something way nicer. Or such a response, even from a fallback, can furthermore instruct into getting something better, like maybe you have some cache somewhere where you can get some information that can still be served to the end users. Giving a fallback is not a bad idea. It might not necessarily be one of the best things, but it can help with implementing other components of your architecture. So let's do a fallback and let's implement a default basic hobby dot class. And let's go with it, creating a class. Yeah, so but I said we're in Java 17, right? So I can do this and transform this in a record since I need it only here. And it's way much nicer, right, to use what Java 17 is giving to us. One more thing I need to tell you, when you're doing this fallback, you need to return a type similar, the same type as the original method. So if the original method was returning the type basic hobby, your fallback handler has to return something similar. In this case, a basic hobby. So let's go here and implement the methods and handle this and return basic hobby.empty. So this one is going to return actually an empty basic hobby. It's not going to retrieve much information, but if we're looking this here and we're retrying again our request, it's looking way nicer to get even zeros than an at least top trace, at least from my point of view. Now that we've seen that, I've also put a small picture for you, a sequence diagram of how things are working between activity service and the external API, so that you would know how things were changed between the annotations and how things were like handled between all these. This is not for like me to explain it right now, but this is something that you can like look into a little bit later. Next, we're looking to the ground, into the application level. Let's look at the level of the infrastructure, because the thing with the resilience is not always just something that you can manage at application level. You can also play with the infrastructure, with proxying things to achieve resilience. And speaking about that, we're at a cloud native talk. The application, of course, it will be compiled to native, and the container is going to contain the native version of the app and so on and so forth. And I know there are many options in the cloud native world to do the infrastructure. Yet, as I mentioned in the beginning, I love Kubernetes, and I will focus a little bit on Kubernetes in this part of the talk. And looking into Kubernetes, Kubernetes is coming up, packed up with its own patterns. For example, service discovery. So you have something available there with the platform itself, but with the orchestrator itself. But you can add on top of that. So with an external load balancer connected to your API server from the master, you can also achieve load balancing. It can help you when you have a lot of load, because remember, resilience is not just your application not going down because it didn't handle a specific scenario. Your application not going down when it has a lot of load as well. Then let's look into circuit breaking, retries, and deadlines that can also be implemented at the level of the infrastructure. So Kubernetes is supporting that, and you can do these primarily with Istio, but there are probably some other options available as well there. And then let's look about another technique called load shedding. We need something extra for load shedding as well, and we're going to look into it. But it's nice that on top of an existing orchestrator, you can add a few more things to even achieve greater resilience. So let's look first of all to the load balancing part. You can achieve locality load balancing and failover when you're using Istio. So just by using some simple things from Istio, you can achieve that load balancing situation and also failover when you are under a lot of pressure with your application. Just to give you some small concepts here, the gateway config that I'm going to use is just being used to allow the traffic. It intercepts the ingress traffic and it further sends it to the ingress controller. The destination rule is just picking up the destination workload to handle that specific request. And the virtual service is matching, is doing a matching and choosing the destination. So this is the connection between these. And of course, what we're going to have a service, Kubernetes service deployed, and two versions of the activity application. The difference between the two of them is actually in the Kubernetes labels, which is V1 and V2. The rest is pretty much the same. But we're going to need these two so that we can simulate a little bit about the locality load balancing and failover. And looking at these two, if, for example, this is going to be our scenario, V1 is not going to be available, it's going to have a little problem, a little hiccup, then using Istio, you can specify the load balancer configuration and locality LB setting when it's enabled to have failover from V1 to V2. And let's look on how to do that. Okay. Sorry about this. All the examples that I'm going to show to you are also explained in the README docs that are in the that is in the GitHub. And if I'm going to go to locality failover, which is this one, I see that I need to install a few things. So first of all, let me install a backend app. So this backend Benelux V2 contains the workload, and it contains a service account. The second one will contain the service. Then I need a gateway. If I'm going to look into the gateway, so let's go here to the gateway, make this bigger. You can see here that I have my activity gateway pretty easily defined, and it's connecting everything through the port 80. So, and it routes anything. It doesn't distinguish between the hosts. It's that simple. And let's also deploy the gateway. Okay, let me export the gateway route. Okay. And okay, all I'm going to need is a destination for my two endpoints. And of course, I need my two endpoints. That would be a good idea. And a virtual service to route my application. And I, kept the last thing for the last, because the backend faulty probe is something that is faulty, but not for too long. So this being a Quarkus application, by default, the liveness probe is going to be either on /q/health /live. But I put here /healthy/living, which is not a real path. So the liveness is going to have some problems in adjusting, just temporarily. Please remember that. And this temporality is very tricky to be caught. This is why I'm like doing this the last one. Let's do this. Okay. And now let me do a hey command. So what hey is going to do is going to send 4 concurrent requests during 30 seconds. Disregard the number 10 here, because I was initially thinking of 10 requests be sent concurrently for users. Sorry, 4 concurrent users that send 10 requests. But the -z here is overriding this part here. So it's going to be like 4 concurrent requests happening during 4 concurrent users sending requests during 30 seconds, right? As you can see, there are more requests. So the response was 44 and everything looks great. But let's look a little bit on some other place in Kiali. And maybe I can replay this a little bit. Oh, it's too late. Let me do it. It's very tricky for me to. Okay, try for 30 seconds. It's very difficult to catch this little one. And we go here and do the faulty probe again. Okay, hopefully it's gonna be bad. I hope. In simulation, it's very difficult to catch it like in a bad situation and then simulate it over with hey. Okay. No, it's not the best scenario. Last 1 minute. It's very difficult to trick it. The idea is that when V1 was unstable, V2 was taking over all the traffic, and I would have loved to show that to you, but it's not always something that I can manage to do it. I mean, it should increase the amount of requests, maybe at the end if there's enough time. Those being said, this is the part with the locality failover. So when something is going bad with a version, you can failover to another one because that one is available for you locally there. Now, we talked also about not only load balancing, but there's also a circuit breaker that you can implement with Istio. Why I gave you failover earlier is because oftentimes coming from the developer mindset, the fallback, failover seems a little bit similar to the fallback that we did earlier, because failover, it was providing a response, from another V2, from another application, from another workload, but at least it was giving something to the end users from another place. So failover, similar to the fallback that we've seen earlier in the application level. And if we're looking to the circuit breaker with Istio, here we can do that even more at the destination root level, or destination rule level. So besides the locality LB setting, you can also set up the connection pool and set up how many connections are maximum allowed, maximum request per connection. So you can detect and have the circuit breaker pattern implemented with Istio as well. And let's look, why is that important when something is failing? Okay. This one's clear. First test that I want to do, I actually want to do one where there is not a fail. So just applying things for this situation. So when we don't have any, any circuit breaker, any failover, just using the destination rule and a default virtual service. So nothing is applied when nothing is applied for the two workloads. And let's do this situation. And when I'm going to invoke deliberately an endpoint that is throwing a timeout. So there's always going to be a 504 coming from this endpoint. And it's going to take a while before we see the end results. I split it like 30 seconds to do all these requests. And we're going to compare this after these results to the ones that are done after applying the circuit breaker at Istio level and see why is that improving the situation for us. Just 30 more seconds. We're going to keep this one for the next part. Now let's apply also the circuit breaker pattern for Istio. And we're going to keep the rest the same. The only thing that I need is to change the destination rule. Okay, so this is the destination rule here. And let me export the gateway because I don't remember if I have it here as well. And of course, do the hey again. You see here that I had another command with Siege. So I've used previously another tool called Siege for sending for load testing, but you can also use Hey for that. It's just a matter of choice. I like Hey because it gives you a little bit of more like a total thing and distribution of how the responses were compared to Siege. Either way, you can choose them and work with them. So let's look at how things were. Well, a lot more things happened during 30 seconds. First of all, you see that in 30 seconds before, I was able to send like 56 responses, and this one to get 56 responses, meaning I was able to send 56 requests. But then this one, I was able to send way more. And let me explain you why. Let's start from the summary above and compare them. So we see that the slowest request without circuit breaker pattern at Istio level, it's like 5 seconds, 5 point something seconds. The slowest with a circuit breaker pattern applied to the Istio level, 4.36. The fastest was 2.0 something seconds. And this is where the major importance is with applying the circuit breaker at Istio level. The fastest was 0.00 something. So this is why where thousands of requests could have been sent or could have been served instead of a few tens like earlier. And yeah, probably you're going to see that, but there's still a failure. Yes, there's still a failure, but based on that 503 or 504 that you got in this part, you got way faster. You can intercept things and you can fail over. I mean, in this case, both of the versions of my workloads are returning 504. If I would like implement a different situation for V2, you would like probably get a 200 when the 503 from V1 would have been retrieved that was saying like, hey, something bad is happening. So when the bad things or the bad response, you're getting it faster, you can act upon it faster compared to the other situation where you had nothing to protect you against the response that is not functioning. So you can see here that all this is not pretty much helping you in identifying that there's a problem or in serving many more requests when you're under heavy load. Besides the failover and circuit breaker with Istio, there's another option, another open source option that you can use with Kubernetes named Scooper, which is a layer 7 service that you can implement. It's very easy to install. And you can have some failover with Scooper as well. That's the nice thing of this one. And how the Scooper is working. So once you have installed Scooper, for example, like in our case, we're going to look also into the front end part for this area. When the browser is going to send requests asking for something to the front end, in the namespace or the cluster, because typically Scooper is created for managing the communication across clusters, but you can also use it across namespaces, like in my case, so that I kept it at namespace level so that you can replicate this easier. So when you're sending this post request to the front end is going to say, hey, I need to get some information about an activity. And this can be retrieved by the backend called activity that we looked into earlier, that that's consuming from the board API information. And it's going to go to Scooper first, and it's going to say, hey, give me some information from the backend. Scooper is going to look into the backend that is closer to him, the one from the same namespace, obviously. It's going to ask for information from this one. However, if there's a connection issue, like we saw earlier, maybe instead of board API, it's board APIs. That's going to be retrieved to Scooper. It's going to sense it, and another retry is going to be sent to the other connected namespace or cluster where Scooper is installed. So you can have this connectivity across namespaces and clusters with Scooper and get your information, have this failover implemented alternatively to Istio. If you're interested in how the magic of Scooper works, you have the Scooper setup in the documentation here in the GitHub. And not only that, I have installed the backend. What you need to do for Scooper, you just have to annotate the service, that is going to the backend, in that case, activity, with scooper.io proxy HTTP. And next, you need to do like Scooper init for the if you put -- console, you also get the console. And either Scooper token create, if this is the first cluster or namespace where you're installing Scooper, or Scooper link create token. When you're doing this, a token.yaml is going to be generated for you, and you can reuse the same token across all the clusters across all the namespaces to connect them together. And let me show you how this looks like in this Cooper console. So if you see this one here, these are my namespaces. So this is Benelux, this is CE, DACH, and UKI. So Benelux is the main one, is containing both the front end and the back end. So this is containing mostly the front end, and then the rest ones, the CE, DACH, and UKI, it contains only the back end part. So whenever there's a problem with Benelux, it's fine. The others can reply and can send some information. And this is the console of Scooper. Let's do some requests to the front end. So I'm going to do some requests to get some activities. And of course, the activities are firstly going to be served from the namespace, which is closer, which is Benelux. So you're going to see that everything's fine. But you can see now that the requests are also being served from CE and from DACH, because Benelux has not maybe has had an issue like I showed you earlier. It's board APIs. And then it gets to the next one that it was connected to the Benelux one to ask for information like, hey, can you get me an activity? Goes to C, goes to DACH. Let me see if I can get an UKI. It's a little bit trickier, but let's just check. Maybe if I'm like putting a little bit more pressure. Yeah, finally. So let's go to the Scooper console. I know this one doesn't look that nice. Okay, now it looks nicer. So if we're going to look at the Scooper console, you can see that hobby frontend, which is our front end, has invoked the activity, firstly from here, from Benelux. And you can see that, well, it got some requests, like 27. Okay, afterwards, when it couldn't serve from this one, it went to the other ones. And you can see the bytes that were like sent and all this information here. So you can see the distribution and the failover and how things have happened between all these applications. And for example, I'm going to take down one of the one of my apps. Yes, I'm in Benelux. Let's go to project and go to my activity and take it down. And let's send again. Okay, CE, DACH, and UKI are going to serve very nicely the application. So there's no problem. Things are going ahead like nothing has happened. So give it a try. It's pretty fun. Besides, working with Scooper and, and by the way, you can connect with the information that I gave you there and the commands I gave you there. You can connect as many namespaces as you want if you want to play with this demo. It's very easy to install. But besides looking into like failovers and circuit breakers and retries and all these things, let's look into another technique, load shedding. So load shedding is defined as a way, as a technique to drop some proportion of the load by dropping traffic as the server approaches overload conditions. This is from the site reliability engineering book, the definition for load shedding. And it's something that probably the DevOps engineers are more familiar with, but you should know that it's something that we can implement at the application level as well. I was very curious about that in the past. And I discovered that there is a Bucket4J Java library that you can use for implementing the token bucket algorithm for rate limiting. So you can use load shedding in two flavors, rate limiting or concurrency control. Rate limiting, there are several arguments to work with it. Today, we're going to look into token bucket because we have this nice library called Bucket4J. And what token bucket is saying is that when there is an incoming request to our application, we can choose a few things for that request. Let's say that we have a bucket, that our application can serve as many requests as the bucket size here, named called B. If our bucket is not, if our bucket is full, meaning the incoming request is way over the amount of requests that the bucket can handle, we can choose a few things. We can drop the request, we can prioritize it, or we can send it with a low priority. Typically, you would choose to prioritize it and send it with low priority. No user request should be handled by dropping. We should be ethical with this. We are very careful with what our users want, right? So we should never drop things. This is like the criteria on the token bucket. But if the bucket is not yet full, which is the greatest of the scenarios, you should just normally send that request. And since we're talking about a bucket, this bucket has a refill rate, dotted here with R. And you can see the duration, you can calculate the duration when to refill that bucket by calculating the bucket size over the refill rate. And those being said, let's see how we can implement that in Java. So no more Kubernetes for the moment. Let's go to my activity. And yeah, I have my bucket here. And let me just do it here. Yeah, bucket. Well, make it this bigger. So I've already added bucket for J to my project. And I'm just put here my bucket, and let's initialize it here. First of all, I need to, okay, say this dot bucket. And what do I need? Bucket for J dot builder dot build. And here I'm going to say add limit. Do not worry, I'm going to add a limit to it in a moment. So first, we need also to give it a limit too. So let me get here and say a limit for our bucket. To define a limit, we just need to do bandwidth dot classic. And we're going to say, hey, the capacity of the bucket is 20. But we also need to think how we're going to refill this bucket. And I want to refill it greedy. You can also choose to refill the bucket at a certain interval too. Say greedy. And then refill it with 20 tokens after the duration of 1 minute. So of minutes. I choose for this situation the minute example so that we can do a test and we can see the impact with it. And then you can add this limit here. Interesting fact, you can add multiple limits to your bucket. So you can make your bucket between different limits. And this is a nice approach if you like to refine the rate limiting part at the application level. Now let's use the bucket for the limited key endpoint and go here. And let me think. Okay, so first of all, let's check if our application can accept a new request. So we're going to do, say, bucket, try and consume remaining of 1, because we're trying to serve 1 request, right? If probe is consumed, then if this is true, that means that, well, our request can be served without any problems. I'm going to say response.status, response.status.okay. And it's nice when you're using this kind of implementation in your Java application to also put a header, because this can be interpreted at front-end level and can be later reused. Let's say X-rate limiting, no, X-rate limit remaining, sorry, night. And my memory is kind of going away. Long to string, probe, say get remaining tokens. What you're going to say here is like, hey, this request is okay. I'm going to serve it to you, but you should be aware that there are this many tokens available in the bucket. And then entity and put service get activity by key and dot build. Okay, so this is the first part. But what happens if the probe actually it returns is okay? It's not okay, and the bucket is full. Well, if the bucket is full, then you should wait for refill, and you should get the time left for refill. I'm going to copy paste this shamelessly, and returned response here is not okay anymore. Too many requests. And instead of x limit remaining, we can say that x limit retry after seconds. And here, sorry, don't need this entity because I'm not invoking the backend anymore. And here, string dot value of wait for refill. So this is the part. What have I done? Okay, cool. So this is what I'm saying. Like, there are too many requests to be handled. I'm sorry. Let's go and do some and have some unit test for this one. And I already prepared some things, but move to the right. But I disabled it for a reason. So this can be tested, integration test, not necessarily unit test. So since I said my bucket is like 20 tokens, I can make 20 requests. And for 20 requests, my expectation is for X rate limit remaining to be there. And you can even control the value of remaining. And for the 21st one, the response code is 429. Let me go to where's my running Quarkus app? Here. And since my tests were paused, now they're not going to be paused anymore. I'm going to run the test. So the continuous testing from Quarkus, oh, yes, I forgot something. The service should work, obviously. It's not more board APIs, it's board API. I was so surprised to see that. But you could see the continuous testing working. So if something that you have forgotten to do within your scenarios, continuous testing is like telling you what's wrong at which test and so on. So my assertion was 200, but it was 500 because I have forgotten to put the right URL there. But now all my tests are passing, so everything's fine. So my rate limiting algorithm is working great. And we're going to use this a little bit later into our last part. Now, let's look a little bit about concurrency control based on request priority. This is the second type of control that we can have for load shedding. And whenever we have such great load over our application, we can also, again, use Istio, for example, to sort our requests and prioritize them in a certain way so that some users are served with priority. Remember, we were talking earlier, even with token bucket. Well, you drop, you send with lower priority, and so on. So in this case, you have the opportunity to send with a higher priority the information to certain users. And you saw me earlier that I was using headers. Similarly, you can like use the HTTP headers or the browser agents, for example, to understand which users should be served with priority, which group of users should be served, or which group of requests, to be honest, should be served with priority. And at Istio level, you can do that because we were saying earlier that virtual services are matching and the destination based on a pattern. You can use the HTTP match on headers for the baggage user agent, for example, and you have an example for Safari. So, for example, all the users that are sending requests from Safari, they're going to be served only from a V2. So even if they want to reach to V1, they will always going to be served from V2. Let me see if I can quickly make this. I think I can quickly make this. Just simulate with priority agent. And make it bigger. Just need to apply the virtual service for Safari, the one that I showed you earlier. Okay. And apply this one and make some 90 requests. Because I'm using this one for the agent of Safari, and hopefully Kelly is going to show me the right thing this time. Yeah, so you can see that in this case, all my requests are being served from a V2 because, okay, this guy, forgot about it. Because all of the current requests are coming from Safari, and my virtual service is saying like, hey, when you're matching for Safari, even if it's for V1, go to V2. So that's the situation for this one. Besides concurrency control and load shedding, for load shedding, let's think about auto scaling. Because some of you are going to say like, hey, but wasn't there auto scaling there to help me when there's a lot of load coming over me? The answer is yes, but you can do things even better. You can interplay auto scaling with load shedding. And how to do that? So let's assume that you have an auto scaling condition here based on CPU, for example, and we're going to look into that as well. You can have auto scaling, by the way, based on memory, depending on how and what metrics you have installed and if you have tailored for your horizontal port autoscaler for your, what metrics you have tailored for your cluster. And you have access to configure, but by default, you can, you know that you can control auto scaling based on CPU. So you have the requests coming, then the workload is increasing, and you see it's kind of getting closer to the auto scaling condition. Most of the time when this happens, it's very likely if you have load shedding, for load shedding to help there first to reduce the resource stress. In the end, load shedding, as you saw earlier, load shedding has a duration that is applied until the bucket is refilled, for example, like in the bucket place, in the bucket situation. Load shedding at some point is like stopping. It's not something that it's like continuously happening. You don't want load shedding to happen continuously. You don't want to prioritize low priority all the requests all the time. No, you just need to do that when you are under pressure. So if the increased traffic is continuing, but load shedding has, taking a break, that's when auto scaling should be put into action, so that it gives a break until load shedding can take and reduce some stress. And this technique is kind of helping you also to preserve a little bit from the resources and not just scale instantaneously and add one more pod with another app with some resources consuming just instantaneously and consume a little bit more than probably is needed. Because, the time that this increased traffic continues, it can vary. It can also not last very much. If the increased traffic is not continuing anymore, then it gets to know the auto scale and everything's fine, right? And let's play with auto scaling and interplay. So I've created for you an interplay auto scale scenario. And let me, I think I can do it here. Just clear the situation, clear. Okay. Let me apply. I have to make it very defaulty, so that's why I'm okay. And I'm also applying the backend auto scale. What I did for the backend auto scale and why I need this kind of backend and not another one is because on this one, I have controlled the resources, the CPU, and that is allocated here. And I deliberately under provisioned the CPU on this one, so that I can, trigger the auto scale and for us not to wait forever into load testing this application. And now let's put the auto scale. I already have it in place, sorry. Then I need to do kubectl. How was it? Forgot about it. Ah, yeah. Get HPA activity minus. Okay, so let's watch what's going on here with our. I need to make it a little smaller. So things are going nice, you know. The minimum pods is 1, the max pods 10, the replica is 1. Now let's put some pressure. So we're going to invoke our previous, rate limited endpoint, the activity limited, because we know this one has that token bucket algorithm there. So at some point it's not going to resist under pressure, and at some point it's going to, kick in with load shedding. So we're going to apply the request to the load shedding endpoint. And now we're going to send them. What I did here, I'm saying like, hey, send all these requests during 5 minutes. And we're going to watch for the horizontal pulse scaling policy, how it behaves in the next 5 minutes. But before waiting so much time, I'm going to tell you here what we did. So we simulate the load, we watch auto scaling, and then we're going to look at some results. Okay. So this was the results of something that I ran earlier, where I got 200 for 130 responses and 429 for the rest of the responses. Okay, the too many requests part, it's very rough, and you can like tailor it and refine it even better. On the left-hand side, what we have is what happened with the activity deployment, with the amount of pods that were being done, and what happened with it, so while watching. So let's look at this part here. You see that the auto-scaling part has kicked in starting at this level, when you see 71%. So the amount of replicas were 1, desired 10, 1 was there in place. Now, when 71% was reached, then what happened, auto scaling kicked in to 2. What you should look into is this situation here. You see 428%, then 4 replicas. And even if you're like looking to the next one, okay, when 428% increase of load and the pressure over the deployment was there, and Kubernetes made the math saying like, hey, I need 8 pods. If you're like doing 8 or 5, it's getting you to 40 or 8 or 50, 8 multiplied to 50 for 100. Where's the rest 28% being handled, right? That's the question. Thing is that the rest 28% was handled by the load shedding part. It doesn't say to Kubernetes instantaneously like to spin up a lot of other pods and reach out to the maximum of the level of the load shedding when there's a lot of pressure. It takes also some of the pressure, so it preserves some of your resources. So you can play with this kind of scenario and see all the scenarios here. And this was one of the highest numbers. And even though there's an increased activity and Kubernetes added more pods to it and saying, hey, you need to add like 8, 9, and then a 9 was kept for some time because there's also a cooldown policy that I didn't change. And I went with the default that's available there. But while the workload will decrease, there's going to be a cooldown applied and the number of pods will decrease as well. However, if you're playing like this, but yeah, this one, it takes a while to do something. 5 minutes can be long. You're going to see similar results to what I have here. This was taken to a lot of time to observe. Thank you very much for listening to me. The code is made available on my GitHub at Umbra Resilience. The slides will be shared. Probably I'll gonna tweet them tomorrow morning, please, my time. But I'm gonna share those with you and some extra resources if you're interested in some concepts that I showed to you today. So there are some books that are available that are written by my colleagues. So first one is the one for Istio. If you like to learn more about Istio, you can use this one to learn more. My personal favorite and my personal favorites nowadays, Kubernetes patterns, the one I've read so many times. It's like the Bible of if you know Java and would like to learn Kubernetes. I've heard many colleagues saying that's really nice to learn from it. And many friends. And of course, Modernizing Enterprise Java, it's a cloud native guide for Java developers, since this talk was about cloud native. Thank you very much for listening to me. And now let's talk about the questions.
Well, you've already answered the first question, which was going to be, what should you read for more information? So I'll skip that one.
Okay, thanks.
Yeah. The first real question, it was from a few minutes ago. You were talking about load shedding and you had random hobby resource on the screen. And someone asked if you could give an overview of the components in the folder. So like, what are the classes in YAML for at a high level?
So the classes in YAML. Yeah, I think I can do that by sharing my screen again. I think it would be better.
Sounds good.
Thanks. Okay. So the classes that I have in my project, the random hobby resource is the one that is containing the endpoints that I showed earlier in the consumption. And this is what my backend, the so-called backend, is producing. The information that are here in the random hobby resource, most of the time are obtained from the consumed resource, which is from activity service, the one that's registered as a REST client, and is containing some implementations to get activity by type, get a random activity, get activity by key, or get activity by accessibility. So there are some implementations for consumption of the board API endpoint. And last but not least, I have three classes: basic hobby, random hobby, and complete hobby. So the basic hobby class is containing some basic information. I just played around it. I could have made just one class, but I wanted to play with sealed to the new sealed keyword, so that since we're talking nowadays a lot about Java 17, and we should talk even more about Java 17, I wanted to give you also a small example on how you could use sealed classes to the small hierarchy. And also because sometimes when you're consuming an endpoint, you don't need all the information from it. You just need to trim from that information. Or when you need to expose some information to your end users, you can have different classes to give that information, not just put everything in one place. Personally, I prefer not putting everything in one place and then skipping and annotating. So I have created basic hobby to permit inheritance to complete hobby and random hobby, which are more complete. The random hobby is just containing the cloud ID and worker ID, the one that I'm reusing at the front end level to know from which deployment things have come for Scooper. So these are more useful when I use that with Scooper. And complete hobby is also having information about link and accessibility, which were also retrieved by the API. But links and accessibility are not information that maybe I would like to expose to my end user all the time. And you can see that, for example, because complete hobby is not anymore, it's not extended by anything else, is using the non-sealed keyword. And similar to random hobby is using non-sealed. So that's pretty much with the class hierarchy. Regarding the YAML that I have here, you have the explanation for all of it into the README of the GitHub. Yes, because I give for all the scenarios I've given what I've used. So first of all, so I have all the scenarios documented in the README, not in this one, in the big one. Sorry. But to give you all the exterior examples, simply run all of these, and I'm documenting all of these there. But you have the installations for the two endpoints. So I've used for the activity deployment, the one that I've used for the Istio demonstration, I've used Benelux and Benelux v2. But sometimes, to demonstrate the faulty situation, I have the faulty probe to replace v1. Or I had another faulty one that I was using. Oh yes, and the auto scale one that was replacing v1. It just didn't want to play with too many resources here. The differences between them is that I'm just showcasing some situations when things can go bad. As I said earlier, for auto scaling, this one is really bad provisioned, so that I can trick the auto scaling into jumping way easier in those 5 minutes. Otherwise, it will take a lot of time. And the faulty probe one, as I said earlier, with the liveness is pretty much for like showcasing temporarily problem. Everything is very, very similar between all of these. It's not like they're very much different in terms of YAML. They contain a service, a deployment, and a service account, because we shouldn't forget about the security part, at least also for Kubernetes, and deploy using a service account name, not randomly without anything. And the rest is explained for each of the scenarios. And then in every of these shell scripts, so that you would know what paces to do. Most of the time, for the Istio scenarios, you use a gateway, a destination rule, the one that I'm specifying here, and a virtual service. So I kept all these three together so that you don't experience, much difference between the scenarios. I know that sometimes, to demonstrate similar situations, you can go with less, but I didn't want to create a lot of friction. Awesome. I hope that this answered the question.
It does. We currently have 2 more questions. If anyone listening wants to ask a question, you have 2 questions worth to get it in the chat. December was an unlucky month between Log4j and the AWS outage. What do you think people's takeaways should be from the AWS outage in terms of resiliency?
Well, in terms of resiliency, I would say that for that one, I briefly followed it. I pretty much prefer multi-regional deployments, but it's not something that is affordable to all of us. I mean, picking in the economy of the applications. And sometimes even because most of the time applications do not, or sometimes applications do not need to be deployed in multiple regions unless you have specific requirements on that and you serve those regions. I would say ideally, yeah, if possible, multiple zones, and it can happen to anybody. It's not something that we should like look to the provider and say, yeah, such a bad thing, what we can, but it's a good thing that the provider stepped in, has remediated the problem, and has also issued statements about it and lessons learned. I think I've seen something about it in InfoQ about lessons learned. And that's something that shows maturity. And it's very nice to be seen. And that's how things should be approached. By the way, if you're more interested in lessons learned, there's a website. Let me see if I can find it. But probably everybody knows it already. With failures,
I really like that you mentioned about it being a conscious choice in your answer, because here we sit on the East Coast. If people were choosing one zone, guess what we chose, right? But I like that you said it's not a problem as long as you know what you're getting into. There's lots of things that can be down for a while, but the people who are caught by surprise were really caught by surprise.
As much as we would like to say that, yeah, we're going multi-zone, if you're going to your business users, your business, and you say, I believe that it would be better if we're going multi-zone, because yeah, this would guard us from these kind of situations in the future. There is a chance for you to convince them. It depends on your negotiation skills to convince them to go multi-zone. But there is also another chance for things not to go in that direction as well. Sometimes I've seen applications, choosing multiple zones because they were serving customers from different areas, and you can then, even if you're like on East Coast, you can balance to the others. But it can happen. I mean, so many enterprises nowadays, they're not all over the place. So yeah,
we're in New York. That's clearly the center of the world.
Oh, I love New York, so I couldn't agree more.
And our probably last question is, there's a lot of libraries out there around resiliency. There's Resilience 4J, and Netflix has a library that I'm probably pronouncing wrong, Hystrix, use some more vowels. What do you think people should consider in choosing a resiliency library?
By the way, Hystrix is not supported from what I remember from 2018.
Okay, so whether it's supported sounds like a good criteria to check on.
From what I remember, I think it's not there. Resilience 4J has replaced it. That's from my memories, from my spring memories. I remember that was decision. Well, when searching for resilience and what to use for resilience, definitely look for something that adheres to the standards. And that's something that is for all the software that we're using. We should look for software that adheres to certain standards, and open standards, by the way. Because if you're looking to a standard that is belonging to a certain vendor or closed source, it might be temporarily good for you. And nowadays there's so many options available. Open source is also good, is great, is awesome. So if possible, open source with an open standards, that's the best thing ever for choosing libraries. And do not worry. If you're using some security scanners, for sure, if you're choosing something that's not very popular or widely adopted or very standardish, there's going to be something warning you that you're not using the right thing. And also, you should choose something that has a strong community around it. So this is where open source is very important. Where there's a strong community behind a library, you get a lot of documentation, you get a lot of answers, people being open about helping. The case of Log4j, there was a lot of people helping.
Okay, cool. And that is our questions for the day. Awesome talk. I'm going to turn it over to Rodrigo to talk about how we're going to draw winners.
All right. Thank you very much, Jean. Anna, I know it's late for you, so if you want to go to bed and have some rest, feel free. We're going to do the raffle now. So thank you very much.
I'm going to stay. I want to see who wins.
Thank you for joining us. And I hope that the next one will be in person. Right.
I hope so too. I miss New York. I truly miss New York, and you all. So
thank you again, Anna. And then now for the raffle, I want to call Barry. Barry has this magic wheel, and he was going to explain the rules of the raffle.
Okay, and you should be seeing my magic wheel right now.
Yes.
You are seeing it. That's wonderful. So the magic wheel has numbers 0 through 29 on it. What we'd like everybody to do is to take just a 20 seconds to think of a number between 0 to 29, type it in the chat window, and we'll find whoever's closest to the number that I roll, a few people. And the winner is modulo 30. So if you've got 0 and it comes up 29, you'll likely be a winner. Anyway, type a number in, and when people are done typing, then I will start the wheel.
Perfect. Let's give a couple seconds. And we're going to be raffling the JetBrains license. So it's valid for any product of JetBrains, IntelliJ Ultimate inclusive. So, but you are free to choose some other IDE if that's your preference. And the license is valid for 1 year from the time you activate it. All right, we have a few entries. Let's give 10 more seconds. All right, that would be fun to find a winner here. No, Frank, you cannot do that. I think we're good, Barry. I think you can.
Are we ready to roll?
Yes.
There we go. Okay, yeah. And as I tried last time, tried this before, was to have a musical background while I was rolling the wheel. And once again, I'm offering a prize, that being a hearty handshake as soon as the COVID is over, to anyone who can identify the music that's going on in the background.
Yes.
If you can hear it, I hope you can hear it. So here we go.
Justin's trying to break your wheel as well. I think that we should change it to the final countdown. All right. Number 23. I see 22. I see 24. 23, right on spot. Sunil Palicha, number 23, right on spot. Right. Sunil, please send your information to info@javasig.com. Barry, let's run the wheel again. Let's spin the wheel again.
Okay, here we go. Can I play the music again?
Sure, go for it.
All right, here we go.
Number 8. Arda Mirek is number 8. Let's see if anybody else is number 8. No. So we have Arda Mirek, number 8. So that's 2 licenses. Let's do one more.
Here we go.
All right. Again, the winners. What is that? 19?
It's your call.
Oh, man. Let's say it's 19.
We had 3 people put in a 19 and 1 person who put in a 20.
I should have seen that before.
So want it to be a 19?
Now it's too late for that. All right. So number 20, we have. Let's see if we.
I suggest a rematch among those 4 people.
I think it's fair. I think it's fair. All right. Between the 4, let's see again. Let's ask them to choose a new number. So Jabal, Matthew Larson, Eric Colby, and Cleveter, please choose a new number, and we're going to raffle just among you.
And don't forget, we have to wait a few seconds here because of the delay.
In the meantime, we can admire the colors and decide which is our favorite. I like the color in 28. It's a very nice shade of blue.
I'm a big fan of when there's just a hint of blue, kind of red, and then there's just a little bit of blue bleeding through. I find that that's very appealing.
How about you, Rodrigo? What's your favorite color on the wheel?
I'm colorblind, Jean.
Oh,
Completely? Can you see any color?
I can.
Okay, we need one more number here.
All right, how many do we have here? All right.
All right.
Matthew.
Closest is,
All right.
closest is the winner, okay?
Closest
Yes.
the winner.
and they
Unless-
pick different numbers, so this is great.
Well,
I
let's
hope
we
it's
don't
not-
get right smack in between. There we go.
I just hope it's not 6. That's fine. No. Eric is the
Yes.
co-oldest one.
Yay.
All right, Eric, you're lucky winner of the 3rd JetBrains license. Again, send your your email to info@javasig.com. I think that's it. Thank you very much, everyone that participated tonight with us. Again, follow us. Here's our Twitter channel or Twitter handle at NYJavaSIG is where we notify all of our events. Since you're here on YouTube, just go click on the subscribe. You're gonna be notified every time we have a new video. All of our presentations we try to record and put here on YouTube for so you can watch it later. Our next event is going to be on February. So if you're following us, you will be notified about it and all the future events as well. I just want to, in the name of the NYJavaSIG, thank you once again for being here with us. We have people from so many different places. We appreciate very much your presence. Thank you and have a good night.